This is the second video for Semester 2, Chapter 8. We're starting with number 17. Here we are dividing these two fractions. It can be written a couple different ways. It can be written with a big fraction bar with the fraction at the bottom, or just use our division symbol. We don't really divide fractions. So we're going to take our 4x plus 5 and our x squared, and we're going to multiply by the reciprocal. There's nothing to factor apart here. So our x plus 5 can cross off, our 2 and the 4 can be reduced, our x and the square can cross off. There's one x on top, there's two x's on bottom essentially, and you can reduce one of those x's out. So you're left with 2 x plus 1 with just an x sitting on bottom. Again, you're dividing by this value. This value is always over 1 if it's not currently a fraction. So we'll factor out this top part, which would be 2x and x. I know that to multiply to be 5, there's only one way to do that, is 5 and 1, so I know I'm going to have 5 and 1 here. If I put my 1 here, I get 2, and I put my 5 here, I want to have a positive 3. So negative 2 and a positive 5 give me that positive 3, but multiply to be a negative 5. So that's working. And we multiply, and the only thing we can factor out of there is 2x plus 5. Factor our x out for a GCF. So this reduces, and we're left with 6x squared on bottom. X minus 1 over 6x squared. We're going to start adding, or subtracting in this case, fractions. To do that, you need common denominators. You're looking for a common denominator, and it's going to be 6x in this case. I'm going to multiply by 2x and 2x. I'm going to multiply by 3 and 3. So that's going to give me 15 over 6x and 2x over 6x. So my final answer here is 15 minus 2x over 6x. We're subtracting still. It's difficult to see what our common denominator is going to be in this format, so we need to factor apart the denominator. X and x, positive 2x, positive 2 and positive 2, add to be 4 and multiply to be 4. This is the difference of perfect squares. So if you notice, they both have an x plus 2, so we're good there. This one has an x minus 2, so I know that this one needs an x minus 2. This one has two different x plus 2's, so this one needs another x plus 2. So what we're going to get is x squared plus x minus 2x, which is a negative x, minus 2. This is going to be negative 6 times x is negative 6x, and negative, this is a common mistake, very tricky, negative 6 times 2 is a negative 12, with our common denominator sitting in the bottom. So now you can collect your like terms. You got your x squared, it looks like you have 7 x's, you have 14 constant values, and then your common denominator. So that's written squared. So that's looking like this one. Here, we could either work the top fraction and work the bottom subtraction and then multiply by the reciprocal, completely work. I can also look here and see that all four numbers are going to go into the number of 24. That would be the common denominator of all the denominators. So I'm going to multiply this fraction by 24, this fraction by 24, this fraction by 24, this one. When you do that, you only do that to the top part of the fraction. So you have 24x over 8 minus 24x over 2, 24x over 3 minus 24 over 6. This is going to reduce to become 3x. This is going to be reduced to become 12x, 8x, and 4. Here we can group some together, and that doesn't seem to match what we have exactly down here, so maybe we should factor our denominator apart. And now that matches much better. This is our final page of Chapter 8, starting with number 22. Just like we did on the other problem, we can look for a common denominator. A common denominator is going to be x plus 5, x minus 3. So I could come over here and multiply by the common denominator to that fraction. Common denominator and common denominator. When I do that, this denominator goes away and I get 3x minus 3. In this case, the x minus 3's cross away and I get 2 times x plus 5 plus x plus 5's cross out and I'm left with x minus 3. Then to clean this up a little bit, we're going to have 3x minus 3. Sometimes we can distribute that through. If you look at the answers, it looks like they didn't necessarily do that. So then we can distribute our 2x plus 1x is 3x. 10 minus 3 is 7. So our answer looks like it would match this one. Here now we're going to start solving. We want to know what value of x would make these two fractions equal to each other. Then we got to check for extraneous solutions, and the main thing we're looking for is what makes the denominator 0 if that happens. So these are two fractions with an equal sign in between. It's called a proportion, so we can cross multiply. Distribute. Add it across. Subtract it across. Get negative 1/3. Here there's a couple different ways we could do it. We could get common denominators, make one fraction, and then cross multiply. Completely work every time. We could find our common denominator of 4x and multiply it to all three pieces, or just the single x and then do the 4. I would suggest in this simpler case let's do 4x, 4x, and 4x because that's our common denominator. So the x's would cross off and you'd be left with 4 times 5, which is 20. The 4's would cross off and you'd be left with 7x. The x's would cross off and you'd be left with negative 9. So we'll subtract the 20 to the other side. Something looks funny. Seven doesn't go into 29. And that's because I would have my 9, my x's would cross off, but it's times 4, which would be negative 36, which would give us a negative 56. Divide that out to get negative 8. Our last problem for chapter 8. Okay, this one would be a little bit more complicated to put both the x and the x minus 3 up there, so I'll show you the other method of just doing it one denominator at a time. The x minus 3's cross off and you're left with 2. Nothing crosses off. You cannot cross the x's. So you get x minus 3 times 1 over x. The x minus 3's cross off, so you have x minus 1. So now we're going to come through with our next denominator. We'd get 2x, x's cross off. We'd have to distribute this in to get x squared minus x. Now we'll move them all over to the same side. So we'll subtract the 3 to get a total of negative 4. We'll add the 3 to get positive. And that's a 0 on that side. So to solve that, we factor it. It has to be 3 and 1. If it was a negative and a negative, it would add to be negative 4 and multiply to be positive 3. So when we set them equal to 0, we'd get 3 and we'd get 1. So in some cases, they'll say that the answers are 1 and 3. And you might get excited and think that was right. But if you notice, if you plug the 3 back in, that's an extraneous solution. So our only real answer is 1. It's okay to have 0 in the numerator, but it's not okay to have 0 in the denominator. So our real only answer is 1.